And welcome back everyone to the third video in our series. This one's going to look at the basics of the config editor, primarily the one for the main board itself. We'll do a separate video for the serial lighting configuration editor at a later date. So I've already gone to my desktop. I've clicked on my dashboard shortcut and I've been brought to the dashboard in the package. I'm now going to click on the Mainboard config editor and let that open up. So here we are. Now this is just a quick overview of the actual configuration editor, and basically what we're interested in are several of the features that I've built into it. Enabling in DOF right here, using DOF, that's selectable by a drop down of yes or no, and it's basically asking you if you want to use this ROM in your INI file because you have a table installed. If you don't have a table installed, it's highly recommended not to bother using this ROM at this point, because the less ROMs you have in your INI file that DOF has to parse through when it starts a table, the quicker your load time is from table to table. If you have 1400 or 1500 ROMs in a file, it's going to parse all that information, and any errors that it comes up against, it's going to be held up in the load time trying to reconcile those errors before just dropping them and moving on. So the fewer ROMs in your INI file, the faster overall your load times are from table to table. Your 5 light bar flasher, below it is where you would enter your information for your flasher bar. Now, I've also got that duplicated on the serial addressable page just because it has fewer boxes, so you have a bigger viewing area to be able to see what you're entering in. Same with the strobe output. Your button lighting is broken down into several different factors. Your first would be what actual switch or solenoid or wire that you're using or lamp value that you're using for the INI file to trigger the actual effect. The speed is basically the blink rate, how fast it fades up and down. Your minimum is the dimmest setting that you're going to fade down to. So you can go all the way down to 0, or you can go down to anywhere between 0 and 255. Your fade up time is the same thing. It's how bright you're going to have your overall effect be by the time it gets to the highest setting that you place in here. And the range is basically an indication that you want to use a fade effect, and you want it to be on a scale of 0 to 255. Now this information is available online in Swiss Lizard's original direct output documentation. It's a little bit of a tough read because he gives you all kinds of information, but it isn't really clearly defined as to what it is that you are setting. For your flicker effect, this is basically what we're using in those settings for your button lighting. AFDN is the density of the flicker effect. For the sake of fading, your density is going to basically be 100% or 250, 255 is the value that you're gonna use. Or sorry, 100 is the value that you use, 1 to 99. Your duration in milliseconds determines how fast your fading actually occurs. So you can have it go faster up than fade down, or vice versa, or you can do the same value for each and have a nice steady gradual fade up, fade down effect. That one is in a duration of milliseconds, and a quarter of a second is generally about where I've set it for the default. So the value there that you'd enter would be 250. Surprisingly, the AF fade variable isn't defined on this sheet, but that's the fourth one, the range of fade, and that's where we set it to be 0 to 250. And I believe from experimentation that that basically is just defining that you're looking for a fade effect more than a flicker or a candle type effect. I'll put the link to this in the description below. It's actually a lot of good information in this manual that comes in handy when you're dealing with configuring your setup. So if we go out of the button section, we get into the ZB launch function. For those of you that use an output from your board to trigger your plunger to know that it's an analog plunger or a digital plunger, this would be the output that you would use. And this is where you would select whether it's off or on. On being I'm using this wire to trigger the plunger to do the internal switching, or no, I'm not. In the case of Zebsport's plungers, you're using an external serial batch file, so this would be off. In the case of, say, a Pinscape or a virtual pin plunger, you may want to use this selection. Your under cabinet back box light strips, that information would go here. And then we get into the physical outputs like your shaker motors, your gear motors, whatnot. Now your shaker motor has several variables that can be defined for the effect that you want it to have when it runs. You can specify a minimum run time. Once again, this is all in milliseconds. So 1000 equals 1 second. You can define a maximum run time. And if you just use one of these boxes and enter in just a numeric value, you set the global runtime, which would indicate that any time the trigger is set off, your shaker motor would run for a predefined specific rate every time. The intensity is selectable by a drop down, or you can enter your own value. It is in hex, so it's set from a 0 to 255 value, but it is a hex value that you have to enter if you don't select from the list. What I've given here is the FF, which is full on. The next one down is 128, which is 1/2 speed. Below that is 96, which is 40%. Below that is 64, which is 30%. And finally, you get 19, which is 25%. 25%, you're pretty much making your shaker motor run at a crawl, but the option is there for you to choose that if you wish. Your gear motor has a selection for the minimum runtime, maximum runtime, same with your beacons. Your fan, once again, has an intensity value that you can run at full speed down to 25%. And your replay knocker, this is where you would put your switch for the replay knocker. Now when we get to the flipper, I've enabled a global timeout feature for the flippers, which is basically just a watchdog feature for those of you using solenoids. If you want to restrict the total time or the maximum amount of time that a flipper, either flipper, can be held on for, you would enter that time in milliseconds in this box here. An average setting would probably be something like 10 seconds or 20 seconds. That should be safe. You shouldn't burn out a coil in that time period of holding it on. And what would actually happen in the background is the timer would be running as that output is held on. And if it exceeds the amount of time that you've set in that timer, it just automatically turns off that output until the next time you press the button. So even if you hold the button down for 3 minutes because you trapped the ball, you actually will only run the solenoid for the length of time that you have entered into this. Now there's a global variable setting for this on the main page of the configuration generator, where rather than enter that value for every single table, you can just enter a global value, and if there's a value in that box, it will ignore this box here. From there you get into your slings, your bumpers, the 3 spare outputs that are left open for custom outputs. They can be used for chimes if people don't want to buy a separate board to run their chimes. And then you can set your add-on board settings. I wouldn't even bother using the serial matrix and custom effects boxes here, as you can control them from the next screen in the dashboard, and you have much more area to view what your settings are as you're setting that up. So that's basically just a quick run through as to what this entails. To show an example, we'll use Attack from Mars once again. So we will select it from the list, refresh the screen, and we now have some values to look at. So as you can see, when you get to your blink settings, what you would be entering is AFDEN, which is your fade or flicker density setting. And once again, that's 1 to 100. You have how dim you want the light to go. In this case, we're going to go down to just under 50%. And how bright you want it to be at its maximum, which is, in this case, just shy of full-on brightness. And we have a range of 250 milliseconds that we're going to do this whole procedure in every time we fade up and fade down. For the shaker, we've indicated our switches for the shaker motor, and we've indicated a minimum runtime of 1000, which is 1 second. So every time the shaker is triggered, it will run for a minimum of 1 second. Because we don't have a maximum indicated, it will run for as long as that trigger is on every time it occurs, without having any kind of shut off on it. And we're running it, in this instance, at 80, 80 being the third down in the list, which corresponds to basically 40% value. Our triggers are separated with pipes because we're using an OR situation. So if solenoid 5 or solenoid 6 or solenoid 8 or solenoid 14 or solenoid 15 fire, then it's going to trigger our shaker motor, and it's going to run on the parameters that we've set below it here in the settings screen. That's pretty much it for an overview. If we made a change in here, we would click the refresh retrieve, and we'd be presented with a pop-up menu that would ask us if we want to save our changes. We would click yes, and our changes would be applied. Changes that you make in this screen are directly made in your database. And because of that, when we make changes in this screen, we have to re-import the database into the file generator, but we'll get to that when we get to that screen. Thanks very much for watching, guys, and I'll be doing another video shortly on how to actually import some ROMs, and so we can see how we actually use this in a real world setting. Thanks again.